Hey Lex, this is the first of the 5 problems that you asked me to do. Before you even begin factoring this problem, you have to understand that in order for this thing to be factorable, this trinomial, the middle exponent has to be half the quantity of the leading exponent. So since we've got a 2 here and a 4 here, it's probably factorable. So let's go ahead and try this out here. What I'm going to do is I'm going to rewrite the rest of the problem normally. Now, what I need is that x to the fourth to look like something squared, something we can factor normally. So if I reduce x to the fourth to x squared, and then raise that x squared to the second power, right? Power times power is going to get me x to the fourth, so I really have the same thing, it's just written a little differently. From here, I can go and factor this thing. What's going to go inside each of the brackets is going to be an x squared. And now all I need are two numbers that multiply to 36 and add to negative 13. Well, that's simple. It's negative 9 and negative 4. From here, I go ahead and set each one individually equal to 0. And I'm going to add 9 to both sides on the left side. I take the square root of both sides, and don't forget, it's going to be plus or minus 3 because we're solving an equation. Here, same thing, I'll move a little faster. It's going to be x squared equals 4. I take the square root of both sides. X is going to equal plus or minus 2. All right, so that's the first one. Hang on. All right, Lex, here comes the next problem, number 2. I'm going to rewrite this as x minus 6x. Now, rad x is the same thing as saying x to the 1/2 power equals 0. Now again, we have to make sure that our exponents have the same distance. This is 1, this is 1/2. It's the middle exponent is still half the quantity of the first one, so it's going to be factorable. And so again, what I'm going to do is I'm going to rewrite this into something that's being squared. Minus 6x to the 1/2 plus 8 equals 0. Well, a good way to kind of remember this is whenever you do this quadratic technique, what's going to go on the inside is going to be the same value of exponent that the middle term is, right? X to the 1/2, and we can even check x to the 1/2 squared. If I multiply 1/2 times 2, I am back to 1. And so I really have the same problem. It's just written a little differently. So from here, I'm going to go and factor this again. So what I get is I'm going to put one of the brackets in each, one of the quantities inside this bracket in each factored bracket, so x to the 1/2 and x to the 1/2. And then I need two numbers that multiply to positive 8 and add to negative 6, so that's minus and minus. It looks like 4 and 2. Now, Lex, how this problem is different from the last one is this is x to the 1/2 minus 4 equals 0, and this is x to the 1/2 minus 2 equals 0. I'm going to go and rewrite these so that they look a little more easy to handle. Remember, we converted rad x into x to the 1/2. I'm going to go and convert back. X to the 1/2 is really rad x minus 4 equals 0. Now I'm going to add 4 to both sides. So I get rad x equals 4. Now instead of square rooting both sides, because x is already being square rooted, I'm going to square both sides. And so since I'm squaring both sides, I don't need to do plus or minus. X really just equals 16. Here I'll do it a little bit differently. X to the 1/2 equals 2. Now squaring both sides is the way to go. I'm just going to keep it in exponential form. So 2 times 1/2 is 1. So that's x equals 4. And again, I don't need plus or minus because I'm squaring both sides, not square rooting both sides. All right, hang on, let me get to number 3. Number 3, they're asking you to factor a couple things that are actually really, really complicated. So again, just look for this common difference here. We got an exponent of 2 on the first term, an exponent of 2 on the second term, and the terms are the same. They're 1 plus x over x. So what I'm going to do is I'm going to do a substitution here. I'm going to say let k equal 1 plus x over x. So what I'm going to do is by doing this, I let k substitute in for all of these values. So go and change colors here. That means that this thing here becomes k. This thing here becomes k as well. So what I really have here, if I let k equal the big thing, is k squared minus 11k plus 24 equals 0. Now, if I gave this to you, you wouldn't think twice on how to factor it. You would know that this is really k minus 8 times k minus 3. All that's left now is to let k equal what it really did equal, which is this 1 plus x over x. So what I've really got here is I've really got 1 plus x over x, change colors, minus 8 times 1 plus x over x minus 3. Right, you see how I let k out of, it's almost like putting it in a cage and then I let it out of the cage. So now I let it out of the cage, it's the big thing again. So now, don't forget, all this equals 0. And now what I'm going to do is I'm going to solve each one. 1 plus x over x minus 8 equals 0. 1 plus x over x minus 3 equals 0. So I'm going to move through these a little fast. So I'm going to go and add 8 to both sides. So I get 1 plus x over x equals 8. Multiply both sides by x. 1 plus x equals 8x. Subtract x from both sides. 1 equals 7x. X equals 1 over 7. I apologize if that was a little bit fast. Maybe I'll go through the second one a little slower. I'll add 3. I get 1 plus x over x equals 3. I'm going to multiply both sides by x. I get 1 plus x equals 3x. And now I subtract x from both sides. 1 equals 2x. Divide both sides by 2. X equals 1/2. Okay, now just to be sure, x equals 1/7 and 1/2. You just want to make sure that that's okay. The problem is that we got an x on the bottom here, and when we divide by an x, we have to make sure that x doesn't equal 0. None of the answers I got equal 0, so I'm good. All right, so it's just a little problem in the domain, or a checking of a problem in the domain. I have to say, I said this before, this is a really good book. I wish we had a book like this. Okay, 3 over x. Oops, I usually pause for this. Sorry, hang on. All right, here comes number 4. First thing I'm going to do is I'm going to move these up to the top. And that's the only other layer that they're putting on this problem. They're going to make you move things to the top. So if it's 3 over x, hopefully it makes sense that it's 3x to the negative 1 minus 11x to the negative 1/2, right? Because rad x is really x to the 1/2, and that's on bottom, so if I move it up to the top, it's going to be negative, and that's going to equal -6. So I'm going to add 6 to both sides. So I get 3x to the negative 1 minus 11x to the negative 1/2 plus 6 equals 0. So now I'm going to go and factor this thing again, and this is similar to the rules of the first two problems. I'm going to go ahead and create something that's being squared, and I got to remember there's a 3 on the outside, minus 11x to the negative 1/2 plus 6 equals 0. Well, again, if you ever fall short, just throw in the middle term. It's x to the negative 1/2. But just double check, does negative 1/2 times 2 equal negative 1? It does, which means that we can factor this thing. I've got a 3x to the negative 1/2 and an x to the negative 1/2. All right, so I need two numbers that multiply to 6 and add to 11. I believe that's going to be a 2 here and a 3 here. But let me just check. I've got a 9 and I've got a 2. 9 and 2 does equal 11, and 2 times 3 does equal 6, and they're both negative. Okay, so now this problem is going to get a little more complicated. Actually, I'm going to go ahead and cut the problem. Hang on for a second. And I'm going to do this and move back up. So if I lost you at any point, go and just hit the rewind button because I can't access that problem anymore. Paste the new problem in there. Good. Okay, so now I'm going to go and separate this out. This is 3x to the negative 1/2 minus 2 equals 0. And on this side, I've got x to the negative 1/2 minus 3 equals 0. Similar to a regular equation, I'm going to add 2 to both sides, so I get 3x to the negative 1/2 equals 2. I'm going to divide by 3. So what I get is x to the negative 1/2 equals 2/3. Well, what I'm going to do is I'm going to go and switch x to the negative 1/2 back. X to the negative 1/2 is really 1 over the square root of x, right? And I'll even do this side work here for you. X to the negative 1/2 is really 1 over x to the 1/2, right? Because negative exponents flip things to the bottom. And x to the 1/2 is really 1 over rad x. And that's how I got to this step here. I'm going to delete this side work here. Okay, so now that I've got two fractions equaling each other, I can go and cross multiply. So 3 equals 2 rad x. Go and divide both sides by 2. So I say rad x equals 3 over 2. I'm going to square both sides. So what I get is x equals 9 over 4. And remember, I don't need plus or minus because I'm squaring both sides, not square rooting both sides. All right? So that is the first half of this problem. The second half is right here. I'm going to add 3 to both sides, and I'll show you a little trick also. I'll go and jump straight down into 1 over rad x equals 3 over 1. Since I'm going to flip the left side upside down, I can flip the right side upside down, so it's really rad x equals 1/3. Square both sides, so I get x equals 1/9. And again, no need for plus or minus because I'm squaring both sides. Okay, hang on for a second. All right, Lex, here comes the last problem. Now, a couple things about this problem. One, I'm not sure if you wrote it down correctly because I'm looking at your message real quick and you can see it. You wrote down x squared minus 3x squared, and I don't know if this is correct. It seems like this should just be 3x because they need to have the same terms in common. But again, send me a message if I wrote it down. If I'm the one who wrote it down incorrectly, just let me know. But I have a funny feeling that this problem is actually supposed to look like this. Now, if in fact the problem is this, then I amplified, right? I guess I changed the color of the x squared minus 3x's to show you that what you really have here is you really have one thing and you're subtracting 4 of those things. So one thing minus 4 things is negative 3 things. And those things happen to be an x squared minus 3x. And then somehow you got this negative 12 randomly hanging out there. So from here, it's simple. You just subtract 12, add 12 to both sides. So you get negative 3 x squared minus 3x. And I'll go and quit highlighting it, equals 12. I'll go and divide by negative 3. So what you get here, I'm going to move this down here, x squared minus 3x equals negative 4. Now, if I move all of the stuff over, I'm going to get x squared minus 3x plus 4 equals 0. Now, the problem with this, and this is why this problem is kind of throwing me off a little bit, is that you can't factor this. And I don't know if this is just because the problem is how it is, but when you can't factor something, you have to use either the quadratic formula or completing the square. I'm going to use the quadratic formula because the middle term is odd. So a equals 1, b equals negative 3. C equals 4. I almost made a mistake there. So I'm going to say negative b plus or minus the square root of, now b squared is negative 3 squared minus 4 times a times c all over 2a. Okay, so let's go and clean this up a little bit. Negative 3 is 3 plus or minus the square root. Negative 3 squared is 9 minus 16. So that is, so right, negative 4 times 4 is negative 16. So 9 minus 16 is negative 7 over 2. Now, the square root of negative 7 produces an imaginary number. So what you have as your answer is 3 plus or minus I rad 7 over 2. And that's what x equals. Now, with that problem, like I said, that problem gives me a little bit of pause because I might have written it down incorrectly. Let me know. Hopefully this helps. See ya later.